let's get into the next part. We'll see what are some of the physical design of AVs. So AV autonomous vehicles have multiple sensors, as I told you. So just see each of the sensors. So we have LiDAR here, we have radar sensors here, and then a camera installed here. And this is not the same for every autonomous vehicle. Google has proposed a different place for different sensors. NVIDIA has proposed a different place. Tesla has proposed a different place. But just we need to understand how generally, an autonomous vehicle looks. So yeah, this is what it sees. When you talk about the autonomous vehicle view, so all these things that are in this color are of camera view, as you see, and in the color of thick blue, it is a long range radar. And then if we have the red part, it means different sensor altogether. And if we have something like this gray color, it's camera. So this is how the cameras are seeing. So this blue is basically radar, and this is ultrasonic. So yeah, these are some of the sensors that we have, and that's how they see it. This is used for emergency braking, some of them used for pedestrian detection, surround view, blind spot detection. So yeah, every sensor has its own importance. So this is the LiDAR sensor, and this is the LiDAR map. What do we mean by LiDAR map? Is simply the sensor which is mounted on top of the autonomous vehicle. It takes a 360 degrees rotation, and then it gets the map, and the map is in the form of a point load. Point load is simply XYZ coordinates. So this is a 3D coordinate space. Probably the car is here. It is swirling those, the LiDAR points. It reflects back after hitting the obstacle. And then, we can see the map, something like this. We'll see what LiDAR is. So light detection and ranging. So that's what LiDAR means. It consists of an emitter, a mirror, and a receiver. So you have an emitter which emits the laser pulse. It hits the obstacle. It gets back. It kind of does 10 to 15 revolutions per minute, which means that it completes one revolution. It releases around a lot of pulses. So it hits them and gets back. So that kind of revolutions will happen 10 to 15 times. So just imagine how much data it is getting from a single cycle. So when an autonomous driving car has to travel from here to here, let's imagine how many revolutions it is making. And just imagine how much of data it is getting, and we need to store this data somewhere, and we need to process. So that's all a challenge technically, but it can map the whole world in front of it. See, the car is here, but it was able to map the pedestrians, the trees, the traffic lights, the bus stand, some of the vehicles. This is a car and this is a car. It was able to map all these things solely because it is taking the 360 view. And this is one of the most important and the primary sensor which is very much needed for any autonomous driving vehicles, in order to map the 3D objects or 3D based processing and everything. And then radar. So long ago we have learned about radar. We listened what is radar. Radar is used in many areas across several cases. Radio waves are being used for multiple scenarios. So in case of the car, we use them specifically for avoiding the accidents. So if you see primary form of the radar, this one, adaptive cruise control. This is a long range radar. A car is there in front of us, or when a pedestrian is walking in front of us, this radar will detect that, will send the pulses to the back, and then we'll understand, okay, there is some object in front of us, so let's stop. So for the sole purpose of that, we use radars, especially for collision, warning, for adaptive control, for cross traffic alert. For such kind of things, we use radar. We cannot detect the objects using radar, but the sole purpose of radar is to understand, there is some object. We don't know what it is, but there is something there. So let's stop kind of scenarios. Yeah, so traditionally radar sensors are used to detect dangerous objects in the vehicle path, more than 100 meters away. So there is some huge truck, somewhere at the very far, and the human can see the truck very easily. But still, the autonomous vehicle, which is going at a speed of 80 miles per hour, it still should be able to understand that there is truck somewhere 100 meters away, and it need to adjust itself. Okay, there is something over there. Let's stop, speed down to 60, something like that. So in order to do such kind of things, we need to have the radars. And yeah, accident prevention systems. So that's the primary intention of having a radar. We need to prevent the accidents. And yeah, the radar chips between 10 to 11 gigahertz over millisecond period. This is particularly depends on the kind of radar we are using. So if it's a short radar, we'll have a different kind of a frequency. But if it's a long radar, we'll have almost 10 to 11 gigahertz over a millisecond, which is pretty fast. Yeah, it's very much helpful during the nights. This is a very important point because during the day, the camera or the LiDAR works especially well, but during the nights, camera doesn't work, LiDAR doesn't work because it cannot map the environment when there is no light. In such cases, a radar is the key. And still there is a challenge. So during nights when there are no street lights, how do we map? Is a still problem to be solved in autonomous driving world, and radar is one good solution for that. And then cameras. Cameras, as we all know, it will take the scene in front of us, it will capture those images, we will process those videos, we'll do object detection, 2D object detection, we'll do path planning. All this happens with the help of camera because whatever we see with our own eyes can be seen with the help of camera. Yeah, I don't want to get into what camera sees because that's what everybody knows, like what we are seeing through camera. So it's a sensor that we all know. And then ultrasonic. So this is basically sound. Ultrasonic in a sense, it's simply ultrasonic waves, the sound waves that which we have, across this point and this point. So those are mainly meant for understanding if there is anything that is so close to us. For example, even in some of the cars that we have right now, when we are moving back, when we are getting close to some of the obstacles, we get a slight alarm saying that you're close to some vehicle. That is purely because of ultrasonic. So when we are reversing, or when we wanted to park do a parallel parking, or when we wanted to park near some curb, something like that, we need to have some assistance, and that's purely with the help of ultrasound. So ultrasound can send the waves, and then they understand how close we are. So for the closest objects, ultrasounds are pretty helpful. These are also useful when there is no light. So those are better than LiDAR in those cases. They are helpful when there is no light, when there is fog. In all those robust conditions, ultrasound and radar works perfectly. And yeah, so these are some of the ultrasonic sensors. This is how they look. These are from Bosch brand. And yeah, they are not very expensive. They are being installed currently in almost every car. They are not too expensive. But the only problem is they lack the range. They cannot assist something very far. For that, again, we need radar. For shorter distances and for shorter areas, we need this. Yeah, so GPS and odometry. Odometry is simply the vehicle speed at which the steering angle is rotating, and also how much pressure is being applied on the brake. All these information of the odometry, that information is stored in the car, as I told you, in the form of connected vehicles. So that information is also shared across other vehicles. So that's the part of the odometry sensor. It calculates the vehicle speed, acceleration at which it is moving, all those details. And then GPS. GPS, we all know where we are heading to, where we are exactly. And if I input some location, let's say I need to go to some X location, and yeah, we need to understand where X is and what's the navigation path in order to correlate with where we are exactly, in order to localize itself. We need GPS, and of course GPS is pretty much needed for autonomous cars to move from some X to Y. Yeah. And what is end-to-end learning in autonomous vehicles? So yeah, a powerful end-to-end trained driverless car will be able to steer the control on its own without lane markings, and still with minimum training data. So as I told you, end-to-end learning is a very powerful technique in where we need to train the autonomous vehicle with deep learning features, and it should be able to control the steering on its own without doing a number of steps. Yeah, this is a method proposed by NVIDIA, and they have implemented it in their own cars, and they have got pretty good results. So let's say we have left camera, right camera, and a center camera. So when I say all these things, these are all placed across. Let's say in a general car we have two mirrors, right? So let's say we have two cameras across two mirrors, and then we have one more camera at the center, probably at the part of rear mirror, and it is seeing what is in the front. And if we have that information, we do a random shift and rotation of all those images. Okay, we have the camera images coming in. We take a shift and rotate those images, and we send those images to a convolution neural network. So I'll just give a brief of what is convolution neural network if some of you doesn't know about it. But yeah, just park it there. So CNN, what it does, it just extracts the features of these images. When I say features, so it understands what is there in front. So that's what CNN module does. And yeah, so we have a steering vehicle, and then the information at which the steering is being rotated, that value, whatever the degrees we have, that value is also given to the module. And then when we actually see the camera random shift and rotation, we process to CNN and we come up with some angle. Okay, let's say I say 40, it needs to rotate some 20 degrees and the steering angle is at some 19 degrees. So that difference of 1 degree will be sent as an error to back propagation, and we'll update the CNN saying that, hey man, you need to make sure that the steering angle at which we have to see is not 19 degrees but 20 degrees. This is what happened when we are training the neural network. So this is also about training. I'm not talking about the testing. So we need to train the neural network first. So in that case, so let's say the steering has to rotate at 20 and we are looking at 15 and then the error is 5. So we'll tell the CNN, hey man, when you have the camera, something like this, you need to rotate by, like 20 but not 15. And then the CNN gets adjusted. It learns and then it gives back the command to the steering. So that is called end-to-end learning. And while testing, what we do is we have the center camera, we have a CNN, and then the CNN just gives the network computed steering command. It says, okay, 2 degrees or 5 degrees or 6 degrees. And then it just, sends the command. The steering itself will move by 6 degrees. This happens while we are testing, and this happens while we are training. So somebody might ask, while we are training, we are taking left camera and right camera, but while we are testing, we are only taking center camera. Then how it is possible to do it? That's the interesting part of the NVIDIA's research. It doesn't take the input from left and right cameras while it is doing the testing part. It only takes the center camera. Still, it is able to work really well because the images that we are taking from the left camera and right camera, we are doing a random shift and rotation of those images. Due to this, what's happening is, due to this shift of rotation, and we are trying to make sure that car sees center but not completely towards the side. So that's where the center camera is pretty much enough to generate the steering command. So once the network is trained, it will be able to generate the steering commands from the center camera's feed. Yeah, so now what? Now the important guy here is a CNN. So what CNN does? Let's not get into the deeper part of it, but if we have a car, this is all whole CNN. What CNN does is it will extract the features of the car. So it will identify whether it is car, truck, van, or bicycle. So it does this classification part. So the concept of the feature learning happening from the convolution neural network maps, this is something that we call as feature learning, which is happening here from the road, from the lanes, from the roads, or from the lane markings. We are learning now, and then we are classifying. Okay, so this is the architecture used by NVIDIA, in order to do the process. So CNN, when I say CNN, it doesn't have a specific architecture. It can have any number of convolution layers. It can have any number of pooling layers. So this is a convolution layer, and then this is a pooling layer, and then a convolution layer, and then a pooling layer. Pooling is simply in order to reduce the size. Convolution is where we are getting the convolution feature maps. Here we have 1, 2, 3, 4, and 5. Probably we have 3 convolution layers. Okay, let's assume. In this case, this guy have more than 1, 2, 3, 4, 5. They have 5 convolution layer feature maps. In such ways, there is something called as ResNet model, which has 101 layers. There is Inception model, which has more than 50 layers. And then there is DarkNet, which has 53 layers. So people have come up with multiple architectures with as many layers as possible. And NVIDIA has come up with a model which has just 5 layers. And then it has a fully connected layer, which gives the results. So this is how NVIDIA has come up with their own architecture for finding the lanes. Coming to the career paths, many companies are investing in autonomous driving now. And once you learn autonomous driving related courses, and you will understand some of the concepts of the autonomous driving use cases, like deep learning concepts. When I said the CNN, you'll understand what is CNN, how it is being built and all. And so you can be a deep learning engineer. That's one career path, which is booming right now. and an autonomous driving engineer as such. There are some, if we go to some of the foreign countries, not much in India right now, but there are autonomous driving engineer roles across multiple companies. They're offering such things right now, and you can go and be an ID guy. And then software engineer in ADAS. So when I say ADAS, it's Advanced Driver Assistance Systems, and so that's a particular module that is very famous. And you can be also a software engineer in that part, which means that you can learn some of the CAN data analyzing, embedded systems, and all that. But this part that it's slightly different from the deep learning and all. It's based on the physical architecture of the embedded systems that we have in the car. How do we process and all? And a computer vision engineer, of course. So all the camera, all the input of the camera, all the input coming from the LiDAR, we need to process it. We need to do an object detection on top of it, or we need to do an image classification on top of it. So a computer vision engineer will take care of all this stuff. So you need to have this guy also in the stack if you are building an autonomous driving car. And there are many other career paths too. You can be a radar guy. You can also be a deployment. If you are a guy in the back end, then you need to take care of deploying all these data sets onto the cloud and then get the data onto your local machines. You run it, and all this process should be handled. And you need a guy who is pretty good at handling databases, how to big data. So it's a whole stack. And these are some of the career paths. You can pick one career path that suits you the best, that interests you the best, and still you can be a guy into autonomous driving. So that's what I can say about career paths. I mean, there are multiple career paths coming up right now. You can pick this particular autonomous driving, and you can actually move into any of those paths. So that's how it is.